turning it on. Oh, it's still not on though. Uh, are we on? I think we're on. We're back, boys. Yeah, here we are, I think. Hey, good stuff. All right. Let's get to YouTube. Just a moment. We'll be there in a moment. Or maybe not, who knows? I'm gonna fill this void with words. Ah. Alright, she'll look. What the fuck is going on here, bud? Well, that's a weird thing. Here's my current YouTube. Look at this. I don't know what's going on here, but it's going on. Very fun though. Anyway, I guess I'll refresh. See if that works. Give some time for somebody to come in if they so wish. If not, hey, it's just an inventory. Here we go. Is this gonna work? Hey, there we go. We're all set up. We're all prepared. We're all ready. Fantastic. Right, so today we're going to be going over the fourth ownership inventory. It's a series of quizzes based on Stack Overflow questions about Rust. I'd love to know how they choose these things. Alright, there's really not much left to this. You got pattern matching, advanced features, and a project. Building a multi-threaded web server. Then it's the end of experiment. We're not going to read through the appendix. Okay. Really, we've got a few sessions left and that's about it. Half a year of my life, probably a bit more, gone to this void. Well, no, an hour and a half weekly. But you know, hey, I've had a good time, honestly. What, 18 pattern matching, 19 advanced features, 20, and then that's the project. I don't know what I'm going to do after this, but I'm going to continue on with these things. I don't care if nobody's watching. It's a good way to have a log of the stuff I've been doing once a week. Or a good excuse for this. I cannot believe, and anybody who's actually been watching this knows how flaky I am. Seriously, with Magel and Silver Sorbet and the rest of them. God, I am a flake, ain't I? But this, I don't know why. I'm here, weekly. Fantastic, isn't it? I am completely shocked. I've missed 3 sessions. I believe 2. But, hey, I'm just going to keep going forward, going to keep doing this, and eventually I'll crash and burn and stop doing this and forget about it. But hey, until we get there, it'll be a good time. Right, so I am simply going to start this quiz. It's an ownership inventory, meaning I'm going to fail most of these. Alright, what compiler error will we get? Add the string s to all elements of the input iterator. Is this a multi-choice thing? Ah, yeah, it is. We have concat all, which is a function taking in an iterator, which implements an iterator of type implements iterator of type item equals string, or where item equals string. I can't really remember the syntax, but hey, who cares? An iterator which holds an item which is a string. Right, secondarily, we're bringing an s, which is a string slice. And we're outputting an iterator with this item equals string, and impl block. Or, yeah, I don't know. An iterator which I don't remember. Then we have iterator.map moving into ensuring that it's moved into this. Sorry. And a, God, what is it even called? I can't remember. A closure. I'm very tired today. A closure which moves S into it. S is moved into this inner.map, and I believe it's then destroyed. Right, so map, I'm assuming, takes S2 and then adds S onto it. Since S is an immutable reference, which is I don't think it has ownership, honestly. I think this might be correct so far. Iter.map does not implement the trait iterator item equals string. I wouldn't know. If that's the case, I feel like that is a very dumb thing for them to have put here. The returned iterator captures a lifetime that isn't in the bounds of impl iterator item equals string. I don't think that's entirely true. If something's brought in, it has to live at least for the life of this function. Perhaps not afterwards. If the issue is with it, the returned iterator captures a lifetime that isn't in the bounds of impl iterator. That could be it. This could be a lifetime issue, honestly. We're bringing in two things and outputting an impl iterator. It doesn't know if it's this or if it's some entirely new thing, so it at least has to be annotated, right? I believe, however, that we're going to get this map error for the movement first. S2 plus S is not valid because S and S2 have different lifetimes? Possible? I don't think so, though. I think that the plus operator on S is just going to add the two strings. Yeah, I don't see that as an issue. Can we just concatenate it like that? I'm assuming we can just concatenate a string. It's not saying anything on it. Oh, we have a little thing here. Yeah, who cares? Right, I'm purely going to guess that it's here. I don't think that it can move out of a shared reference. It doesn't have ownership of it. I wouldn't be so shocked if I got that wrong, though. Right, normally if you try to compile this function, the compiler returns the following error. Hidden type for implement... Oh god, it's literally the same thing, and it's going to do that thing where it makes fun of me. Hidden type for impl iterator equals string captures lifetime that does not appear in bounds. Okay, so it was a lifetime issue. Okay, I'm never gonna really get lifetimes. I'll just understand that now. I'll have to look it up every time it comes up. Assume the compiler did not reject this function, which, if any, of the following programs would 1. Pass the compiler, and 2. Possibly cause undefined behavior if executed. Check each program that satisfies both criteria or none of these programs if none are satisfied. Right? So first, we have a vector string. Right, so we have concat_all, which is the function that simply iterates over. Iter.map just takes a closure and creates an iterator which calls that closure on each element, taking an S2 as the item string. So it's just for every single S2, we return S2 plus S back into the iterator, I believe, which is returned. Back into a new iterator that is returned at the end of this function here. Alright. So we have let v equal a vector vector string from Rust concat_all v dot into iter, and yes, dot collect vector. I see no issue with this. I believe that the main issue, due to it being a lifetime issue, is for the fact that the string here, if it is used again, will have an issue. Same with the original iterator, which is creating a new one. So if we utilize either A, the initial iterator, or B, S, the string, and then utilize it again, that will break. Because it's moved into here, right? So since it's moved into here, S will be destroyed at the end of this. So if we try and utilize S, which is a borrowed reference here, just a borrowed reference here, if we try and use it here, it'll break. Can't do that, can we? Right, so we got we have vector v equals that's fine. Let it equal new syntax, new what is it called? Scope. New scope. Let s equal string from yes. Within its scope, concat_all v dot into iter and a reference to s. S is never used again. It doesn't need to worry about lifetimes. That's fine. It dot collect the vector. It is the output here from that syntax. That's fine. That's fine. That'll output the iterator, which will then, outside of its scope, output the iterator back to it. I don't see an issue here. Yeah, I don't see an issue here. V is not used again, even though it's within I don't think that's an issue at all. I think there's only one. That feels wrong, doesn't it? Unless there's something I can't remember with collecting and iterators. Unless there's something with the owning scope. Since this is returned originally here, and this is a new scope, unless returning it here means that this scope owns it, and thus returning it from this scope might break something. I don't see that as an issue. I think that's fine. Unless this addition is simply adding on, like, part of the string. This isn't actually, like, copying it over. Because I know S does not have copy. Does not implement copy. So adding them on could just be adding, like, hey, here's part of it, and then another part of another string, and we are just concatenating both. And thus, when S is destroyed, if we attempt to utilize S again, it's going to have an issue and be destroyed. You're accessing false memory. So outside of the syntax, where S is no longer in existence, since S is no longer in existence, we can't have a reference to it, and thus, outside of this syntax scope, we can no longer utilize it. I still don't think that's the case, but that is something I'm going to bring forward. We'll see if I'm correct on that. I believe I have gotten 2 wrong so far. As ensuring S to all elements of the input iterator. Of the following fixes, highlighted in yellow, which best satisfies these 3 criteria? Passes the Rust compiler, the mix function preserves the intention of the original code, and the fix function does not introduce unnecessary inefficiencies. Right, so this is just the same thing we've been looking at the entire time. Right, so first off, we add a static lifetime to the string, which means that it must live for the entirety of the application's run. That's not a good solution. Secondarily, we add in 2 separate lifetimes. We have yep. So yeah, the iterator must have lifetime A, S must have lifetime B, and the return must have a lifetime equivalent to both A and B. I think. I don't think I've ever... whatever. Yep, that's probably what it is. Right, so here we have A, which says that the iterator must have the lifetime of A. S must have the lifetime of A as well. And the output must have the lifetime of A. I don't see this being an issue at all. Like, why do this? If this works. If this works, I see no issue here. Right, so finally, we have S is now just a string. And is output here. I don't see that as being a good thing. If this is the issue, and this is the fix, that would suck. It has ownership over its contents of the string. It has a close relationship to its Borel counterpart, the primitive string. So this brings in ownership and then destroys it. Pretty certain. Right. I don't see any issue with this, just adding in a regular generic lifetime. I can't see having one lifetime for one and another for the other as being good. Well, from here, it wouldn't know which lifetime this comes from, but it would have the same lifetime regardless, so I see no issue with this. Let's submit. I hate that I don't have instant, hey, here's if you're right or not. I guess I really just don't understand this. Huh. Adds a displayable object into a vector of display trait objects. We have use standard format display. Add displayable is function add displayable with a generic type which implements display, taking in v, which is a reference to a mutable vector holding a box holding a dynamic display, and t, which is of that type. Sorry, any object of a type that implements display. And then v.push, if you try to compile the program, which of the following just describes the compiler error you would get? Right. You don't have... Right, what's the issue here? What's the issue here? Right, is it that well, I guess I just read this, but my god, is it lifetimes, really? Right, so T may not live through V. T may be destroyed at a later point in time. We're also not... Oh, are we getting... We are getting ownership over T here. So that's fine, but T may not live long enough to be inside of this vector, is my belief. The type T does not outlive the lifetime of the reference. I believe that is the issue. The type T does not live long enough when cast to a trait object? No, that's not correct. The type T may be dynamically sized and cannot be casted as a trait object? I don't know. The type T cannot be boxed if it contains a reference? You can box a reference. Right. I think that is the issue. Right. Adds a displayable... Yep, we got this thing. Okay, what is the compile? Ah, yeah, we got right. We got 1 correct. And by we, I mean me. I have 1 out of 6. That's fantastic. That's a failure, but at least I got the easy one. Assume the compiler did not reject this function. Which, if any of the following, would 1 pass the compiler and not cause undefined behavior if executed? And possibly cause undefined behavior if executed. Alright, so we got let v, which is a vector, dynamic box, vector new, add displayable, v, and 5. Right, so the thing I'd issue is 5, which is being added into it. This is a literal. I don't think that's an issue, actually. Yeah, I don't think that's an issue at all. That's fine. We're not even utilizing v, so that's fine. Let v equal vector box dine display equal a new vector. Then we have, this is almost certainly going to cause an issue, yeah, because it dies here, and then we try and print 0 here. So this will kill it. All right, what do we have here? We have the same issue. Let s equal string hello world. We try and pass s through with ownership, and then it dies. Yeah, that's also going to be a failure. Fuck it. Sure, let's go. Right. Of the following fixes, which fixes it? Right. Display plus static. Don't make everything static. That's a bad idea. Right, add displayable with a lifetime of A, adding a lifetime of A to the displayable, but not to the type. Right, the type's the issue, right? Plus clone would work, but that's a memory inefficiency. What? The issue is T dying. Out of everything here, the only thing I can see actually being... Oh, well, actually here, casting. Casting is here. Oh, yeah, here we go. T is of any type and also... implements display and also has a lifetime of A. We're taking in V, which houses this, and T, which must align with this structure. So this I believe to be the best format. Yeah, that's fine. Yeah, I don't see any issue here. Static is inefficient. Don't do that. Right, I think that's fine. I got 2. I think it was the last one. Let's see. I answered correct. Fantastic. Right. Where did I mess up? I knew I got 2. Oh, my lord. I really messed up this day, didn't I? Right. Cannot move out of a shared reference is incorrect. Let's see the correct answers. Returned iterator captures a lifetime that isn't in the bounds of impl iterator item string. This was the lifetime quiz, I guess. Right, so what is wrong? The issue is the returned iterator captures a lifetime that isn't in the bounds of impl iterator item string. Right, so yeah, we had the same issue as previously. We were trying to add in S to this iterator. S is a reference which may die at some point in time. And thus we are trying to put something into it which cannot be done. The string reference S has an implicit lifetime of A. The closure passed to iterator.map captures the string reference, but the type impl iterator item equals string does not mention a lifetime of A. Therefore, the iterator captures a lifetime not in its bounds. Oh, so the issue is reversed to what I would think. So the issue is not that S has no lifetime. S has a lifetime of A. However, this cannot take in a reference of, something with a lifetime of A? Okay, I think it's just worded a bit weirdly for me to understand. No, I think that it still is the fact that we cannot return something which has a different lifetime than itself. Impl iterator item equals string does not have a lifetime specified, and thus it does not know that S must have a lifetime equivalent to impl iterator item equals string. So we must add in that it can take something with lifetime of A in order to return it, especially with S. Okay, I believe that to be understandable. I'm still not going to remember it, though. Right. Oh, I got this entirely wrong. Right, so I said that this would be an issue, but it's perfectly fine. Apparently, that's not going to cause any issue. The only thing that causes an issue is this. Huh. Yeah, why would that cause an issue? Now that I think about it, what am I thinking of? Did I think that this was destroyed at some point? That must have been it. It's a reference, however, you don't have ownership, you cannot destroy it. Right, so S is printed out, which is fine because it's here. It's living here. That's fine. I see no reason why I should have picked this, actually. Now upon second look. This is fine. I see no issue with this. We're passing it a reference to concat all, which is fine. It concatenates it within this collector. And then we're just printing S. That's fine. S still lives here and it's still owned. Here, I see no issue with that. I'm a bit of an idiot then. Now here, however, yes, it does make sense because S is destroyed at the end of the scope. And also, a reference to S lives within it. That is the issue I see now. Since there's a reference to S inside of it, from the concat all, it returns out something, or an iterator, which is then stored here, and inside that iterator is a reference to S. And so, S, now destroyed, is a freed bit of memory. Now, when we try and collect it, we try and take all of that stuff, and I can't remember what collect does, I don't care. I believe that it takes all of the values of it and returns it as a vector. Yeah, I'm an idiot. Yep, that is what iterator does. So it'll try and dereference S, which is trying to dereference freed memory. Or, well, no, it's trying to utilize S, which is a freed pointer. Not double free, but yeah, anyway. Yeah, that is an issue because of the scoping. Right. If the returned iterator isn't related to the lifetime of S, the memory safety is violated. If S does not live forever, it's not static or a string like a string letter, the return value of concat is used after S is dropped. Then the expression S2 plus S would dereference S. It was a dereferencing. I don't know why I didn't think that. A read of deallocated memory. Horrible. Alright. I messed this up. No, I didn't. I got it correct. That is perfectly fine. Let's read the context. Over the following fixes, yep. To fix this issue, we need to express the relationship between the lifetimes of iter, S, and the return type. The best way to do this is a lifetime variable, and requires that iter and S both live for the lifetime of A, and that the output type also lives for lifetime A, which can be done here. With both, yeah, just A. Both have a lifetime of A. That's fine. Alright, next, we fucked up. The type T does not outlive the lifetime of vector. That is apparently not correct. The type T does not live long enough when you cast to a trait object? It is specifically because it's a trait object? When casting box T to box dynamic display implicitly in v.push, Rust requires that the trait object dynamic display must outlive the vector. However, the lifetime of T is unspecified, so T may not live long enough. Isn't this the same thing? At mutable vector. Oh, I was... Okay, yeah. The type T does not outlive the lifetime of the reference of this vector. That is really the issue, though, isn't it? Does it really matter that it doesn't have a lifetime which is fine with the dynamic display, which is held in this box? I mean, it's the problem with it outliving the entire structure. I mean, sure, if we're gonna get nitpicky, but I see this as getting the same solution. I still deserve an incorrect answer, of course, but still, I just don't see that much of an actual difference. Is there? Does not outlive the lifetime of the reference mutable vector. Right, so yeah, if that dies, then it's messed up, it's fucked. But if the box dynamic display, which is built here... Well, I mean, that's within the code. Who knows where that dynamic display comes from? Perhaps we're taking a box from some random static memory or something, I guess? Or some used thing, I guess? It doesn't really know, so... I guess the issue is underlying within the dynamic display. The box dynamic display, which is being created here. Huh, okay. Right, I got this incorrect. Apparently, this is fine. Which is fine, which is fine. Which is fine, which is fine. This is fine. This is fine. I guess it's because it implements the copy trait? Yeah, I guess because it implements the copy trait, and dying is fine. Because it's copy. It's a numerical literal. So, yeah, it just copies it. A reference to n, and then we add it in here, and then we just push it here. It just copies it. It doesn't have a pointer to it. So n dying is irrelevant. Okay, that is the issue. I'm glad that I am glad that I am over... That I am... fuck. You know what? Whatever. This program is memory unsafe. To create a memory safe violation, the program must create a type T that contains references which do not outlive the vector. For example, adding a reference n where n goes out of scope means before v means the latter uses v 0 is a read of deallocated memory. Yep. Wait, what? No, that is correct. However, the string is incorrect. What? That's fine? I got that wrong. Yeah, that's the error. That's the issue. What? No, I don't understand. We have a reference to n, which is added on. Okay, so yeah, because it's a reference, and the reference is destroyed here. Well, here it's destroyed, but this reference is destroyed here. It doesn't utilize the copy trait, and is thus still there. Oh my god. Then what's the problem? Why does this work? Why does this work? String does not implement the copy trait. You are pushing an owned reference here, and then you are utilizing it. Why is that fine? That should be destroyed. S should be destroyed at the end of this, and then we are trying to utilize it. Why is that fine? I don't understand. Why is that fine? I can grasp why this is incorrect now, though I just rambled about how it was correct. But I cannot understand why this is okay, why this doesn't cause the same error. S doesn't even implement the copy trait. I mean, I understand that it is not a reference, and thus you are simply passing it through. With ownership, but S is destroyed. I mean, S does not have ownership. Okay, so here's what I believe. S does not have ownership. And thus at the end here, since it is unowned, S is gone, but S does not have ownership over the string's memory within the heap. And so, since S is passed down here, and then passed into V, the vector, which is here, V, well, the reference inside of here has ownership over it. Okay, so that is the reason, because it is not a reference which is a borrowing of it, and it is instead passing ownership from it. It is consumed by add displayable. And so the string is fine, because at the end of this scope, the string is not destroyed. It doesn't have ownership, and ownership means that you destroy the thing. S goes out of scope, the variable S is destroyed. However, since it does not own S anymore, it does not own the string from hello world, or hello world living in the heap right now, it cannot destroy it. Ownership has been passed down. Okay, that's fine. So the issue here is that it is a reference that does not own, instead of this, which is an owned variable passed through to add displayable. Okay, now this really shows how little I understand about ownership. I'm going to have to find some other way to learn ownership, because I don't understand it. Obviously. I mean, I have enough of an understanding, once given the correct answers, to go and work backwards towards what the real answer is, what I believe the solution to be, but I can't figure it out on my own. This is obviously some fundamental lack of understanding on how memory management in this works, the borrowing system works. This is a failure on my own. Right, let's read the last one. I got this one correct. I guess I understand lifetimes more than I understand ownership, which, sure. Right. The most idiomatic fix to specify how the lifetime of t should relate to the lifetime of the trait object dying display. Sorry, I did not read that correctly. I don't care. Though, so I'm just going to continue. Here, that means adding a lifetime parameter of a, saying that t outlives a, and that the trait objects also live for at least a. Using a static bound is the same thing but worse. It is simply less expressive, disallowing the vector's trait objects from ever holding references. Putting lifetime of a on the reference a mutable vector reference is not correct and does not fix the compiler error. That would be the other solution, which we did not take in. All right, let's get into design trade-offs, however. This section is about design trade-offs in Rust. To be an effective Rust engineer is not enough just to know how Rust works. You have to decide which of Rust's many tools are appropriate for a given job. In this section, we will give you a sequence of quizzes about your understanding of design trade-offs in Rust. Oh god! After each quiz, we will explain in depth a rationale for each question. Good! Here's an example of what a question will look like. It will start out by describing a software case study with a space of designs. With a space of designs? I don't know what that means. Context. You are designing an application with a global configuration. Example, containing command line flags. Functionality. The application needs to pass immutable references to this configuration throughout the application. Designs. Below are several proposed designs to implement the functionality. Attendants can ask which one is correct. Given just the context and key functionality, all three designs are potential candidates. We need more information about the system goals to decide which one makes the most sense. Hence, we give a new requirement. Select each of the options that satisfies the following requirement. And to see here, we have option 1. Well, let's start from the start. We got RC and ARC being brought in. RC is... God, what is it called again? Yeah, I can't remember the name of it. What is it called? It's called a... Right. What is RC? My God. Right, fine. Source main.rs. Let's use... What is it? SCD, RC, RC. A single-threaded reference count. Reference counting. There we go. Thank you. Very good. Reference counting. And then arc is, if I can remember, I can't actually. It's the same thing, but with synchronous, utilizing, what is it? It starts with an M. We have one. It's under sync. Arc. A thread-safe reference counting pointer. Arc stands for automatically reference counted. Right, what does it use? There's a specific word for the thing that it uses, though. Mutex! Mutex? No, not mutex. Perhaps mutex? What is the thing that it uses? I cannot remember. Huh. It uses the mutable piece. What is it called? Which is necessary. You know what? Spend too much time on it. Below are several proposed designs to implement this functionality. Alright, so A, we have config ref, which takes a lifetime of A, and a reference to config with a lifetime of A. Using a reference. Alright, secondarily, use a reference counted pointer. And then uses an automatic reference counted pointer. Why would we need the configuration to be multi-threaded? Is there ever a point in application design where configuration can be altered by multiple different operations that are working synchronously? I'm trying to think back to applications I've created, and I can't think of one. Though I can think of a theoretical one, where perhaps the state of the configuration changes as things go on, or as things are in different states, per se. But would that be a great use for multi-threading? Or simply... Huh. Alright. The configuration reference must be shareable between multiple threads. Well, obviously the arc is the only option here. Answer is 3. What? The answer would be all 3. Each design pattern that satisfies the following requirements would be all 3. No, not option 2. Right, yeah, since it's a reference, that's fine. It's not actually changeable. This is changeable. Probably. No, it isn't. It's not mutable. But yeah, these two would be fine. I would prefer this because you're not actually altering it. Config is not altered. Unless not config is just never altered. You can use a I can't remember the name of it, but there is a specific piece that you can put inside of the RC in order to have it internally mutable, which is not done here. So that's fine. Right. I think I understand what's going on and have and can continue. Let's go forward. In formal terms, this means that config ref implements send and sync. Assuming config, send plus sync, then both reference config and arc config satisfy this requirement, but RC does not, because non-atomic reference counted pointers are not thread safe. So option 2 does not satisfy the requirement, while option 3 does. Alright, we might be tempted to conclude that option 1 does not satisfy the requirement because functions like thread spawn require that all data moved into a thread can only contain references with a static lifetime. It's not moved though. However, that does not rule out option 1 for 2 reasons. The config could be stored as a global static variable, it is not, using one's lock. So one could construct a reference to a static config reference Yeah, but that's not what's done here. Well, I guess any A is correct, but the struct is not. I guess ref config is never built. It doesn't state that config is built. I guess you could build config with that static reference. That's fine. And static would make sense for a configuration. Right? Not all concurrency mechanisms require static lifetime, such as thread scope. Okay, sure. Therefore, the requirements as stated only rule out non-send types. And we consider option 1 and 3 to be correct answers. Okay. But option 1 is only a correct answer if utilized in a way which is not shown here. I mean, no way is shown here. We are not creating config at any point. Struct config is defined, but it's not given values. And none of these are mutable references, so it can't be given in. Sure, however? No, it is being defined here. I am a fool. Flags are being put in here. So yeah, it is defined, and that is fine. But here, we don't specify a static lifetime. Okay, so forward with this quiz, I'm going to have to assume things can be added in order to make it work, as long as it does not break the this structure. Which I guess makes sense, because we are talking about designing it. We are talking about this from the understanding that we are like systems architects. We are starting a new application, not really system architects, but we are starting a new application and looking at how we are going to implement things, what our standards are going to be. So yeah, just creating a static reference to config would make sense. The real thing that we can't change is this, I guess. Right, we'll move forward with that. Alright. Now, you try with the question below. Each section contains a quiz focused on a single scenario. Complete the quiz and make sure to read the answer context for each quiz. These questions are both experimental and opinionated. Please leave us feedback via the bug button if you disagree with our answers. Along with each quiz, we will also provide we have also provided links to popular Rust crates that serve as inspiration for the quiz. Alright, what do we have? We got 1, 2, 3, 4 quizzes. God, it's like I'm back in school, except I'm failing horrifically, which is, that's still like I'm back in school. I'm kidding, of course. I've passed with flying colors. Question 1 has multiple parts. The box below contains shared context for each part. We're designing a simple asset manager for a game engine. Right? Okay, okay, whatever. Functionality. An API client will provide paths of assets to load and gets back access to the loaded assets. Alright. You may assume that loads happen synchronously and instantaneously. Okay. So I guess races won't really be that much of an issue, or an issue at all. Right. Below are several proposed designs to implement the functionality. So we have a public struct asset manager with all the stuff inside of it. Option 1 returns a reference. We have a public function load, which takes an immutable reference to itself, implemented on the asset manager. And then we take in a path to the path above, outputting a reference to the asset. Not the asset manager, but the asset itself. Which on the asset manager is loading a specific asset with this path. Option 2 returns a mutable reference. We just returned a reference, but this is a mutable reference. The only difference is that it's mutable, that's it. That the reference can be changed? I can't really see too much of a reason for that. You need to create an asset, which must be loaded. Shadowing can use that. Or I suppose perhaps in the asset there are different pieces, like perhaps perhaps the asset is a creature which can be dead or alive. Okay. Return a reference counted pointer. Right, so this is the same, but with an RC. That's it. 4. Return a copyable handle that can be turned into a reference. Right. Drive copy and clone. Public struct asset handle, which is just the U size, which holds the U size. Implement asset manager. We have a public function load, which is immutable, which takes an immutable reference to self, and ePath, which is a path buff, of type path buff, which we haven't described at all. Oh yeah, it's everywhere here, so that's fine. Yeah, I guess I just sure. Asset handle is what is returned. Asset handle is simply a useless, so this is kind of like a pointer. Then we load it by just passing in the asset handle, which outputs an asset. Why would we want this? Why would we want this? I don't understand. Ah, well, we'll see. Select each design option that satisfies this requirement. Once loaded, an asset should be permanently immutable. Right, so the first one is a reference, immutable. Mutable reference. Well, that's mutable. That is mutable. So nope. So we got 1. What about 3? 3 is simply an RC. It's not mutable at all. So 1 and 3. 4 is copyable and clonable thing. Asset handle is not mutable at all. It can be turned into a reference, but it's not mutable. So 1, 3, and 4, I believe, are the answers. 1, 3, and 4. Yep, I can't see this being. This could be the only. This is the only thing that returns something mutable. Once loaded, an asset should be permanently immutable. Yep, that's fine. Asset handle, that just returns an asset, which is a reference, which you don't have ownership over, and is immutable. So, hey, that's fine. Alright, here's the secondary requirement. Clients of an asset manager need to retain access to assets across several short-term borrows of the asset manager. Oh. Clients of the asset manager need to retain access to assets across several short-term borrows of the asset manager. Right. I mean, this would almost certainly be fine. Option 3 is fine. Since this is copyable and clonable, I see no issue with this. The asset wouldn't be destroyed or moved. I don't understand when you would lose access to this. On any of these. When would you lose access on any of these? Short-term borrows the asset manager. I don't understand. Alright, so the only thing here. The only thing here is if you have an asset handle, and then asset manager is borrowed, you cannot have an immutable reference to self in order to use the get. But I don't see that as a problem. That's immutable. That's an immutable reference to self and an asset handle here. That's fine. That's fine to be used while borrowed. So this is fine too. That's fine. Alright, so we have a loadable mute path buff C, which returns an RC which has an asset in it. That'll obviously be fine. A mutable reference to asset, which will be created in Asset Manager. Is that part of the struct? Is the asset part of a reference to part of the struct? Provide pass float and gets back access to the loaded asset. An API client will provide paths of assets to load and gets back access to the loaded asset. Right. I don't see any of these taking away asset. If you have, again, unless asset is a reference to a field within Asset Manager, which at no point does it state this. I don't understand. I think they all keep it. I'm just going to say this. I think they all have access to it after you have a short-term borrow of Asset Manager. If you borrow Asset Manager, you still have access to the asset. This takes ownership over an asset, and these are references to asset. This is the only real difference that would change ownership. And there's nothing stating anywhere I say that asset is part of Asset Manager. So I see no issue. This is creating a new, quote, asset, which is not stated anywhere here to be a thing. So the only place it could live is an Asset Manager, but all of these syntaxes could work if we just added in a public struct asset, which is fine under the original setup. Again, I am simply going to state all of them are fine, and if it says it's wrong, unless there's some actual borrowing issue that I see here, I don't see there being any issue with this. Right. It is important that all assets be deallocated at a single predictable time. Ooh. That all assets be deallocated at a single predictable time. Huh. Immutable reference would be a poor decision, because you could change the asset to something created with another asset manager, could you not? Huh. A reference to an asset's fine. I see no issue here. An RC asset will not get dereferenced until all references of asset are there, so that would be a bit difficult. This has copy and clone, so I don't think that this would be a great solution. Unless RC is what they're talking about, particularly, and the predictable place that it all is deallocated, unless the predictable place that it is deallocated is when it is no longer used, unless that is the issue, I don't see that being a good solution. Right, so immutable reference I don't believe is a good one. An RC I don't believe is a good one. And since it has copy and clone, I don't think this is a good one either. I think the only real solution here is the original asset manager, which gets a reference to the asset, which can then just be dropped at any point without issue. You can just particularly drop it, especially since it's a reference. If we do store it within asset manager, it'll be deallocated when we deallocate asset manager. So I think that's fine. On top of this, we could just store a secondary reference with RC. No, we can. What am I talking about? Yeah, that's fine. I see no issue. So 1 is the only thing that I can think of. But I could be wrong, actually. I could be wrong. RC could be fine. And this section, I don't believe will be fine. Right. We only got 1 correct. Which was the first one. Fuck. Right, so what is... The correct answer is only 3 and 4. What is the issue? Retaining access across borrows means a client wants to write a program like this. We have asset equals let manager equal get manager manager.load some path, returning the asset back here. In this case, secondarily, we have another case equals manager get manager path.load another asset. Yeah, that's fine. And I don't see any issue with 1 or 2. Why would that be an issue? In this case, the lifetime of value returned by load must not be tied to the lifetime of asset manager. Options 1 and 2 require that reference asset and mutable reference to asset must live as long as mutable self. Therefore, the borrow checker rejects programs like the one above. The asset outlives the manager reference. Okay. Never mind, I guess. Yeah, I wasn't thinking about lifetimes at all. Okay, so the reference is intrinsically set to the lifetime of those two original bits. Option 3 and 4 do satisfy because one has clone and the other is an RC, which can have many references over a large period of time. The lifetime of RC asset is not tied to the lifetime of mutable reference to self. Similarly, the lifetime of asset handle is not tied to the lifetime of mutable reference to self. Oh, it's because asset handle is not tied to that mutable reference to self. I see. Thirdly, 1, 2, and 4? Yeah, okay, so the RC is correct, and 4 is correct. Okay, why? To deallocate all assets at a single time, the asset manager must retain exclusive ownership over them. But if you copy a clone, it doesn't have ownership over them. Therefore, when the asset manager is dropped, or otherwise instructed to deallocate assets, it is guaranteed that all assets can... Okay, so here I am a bit upset. It is assuming that within asset manager, you're having asset, which, fine, that's fair. I should have thought about that, actually. I'm not upset anymore. I now understand. It is guaranteed that all of the assets can be safely dropped. Options 1, 2, and 4 do satisfy this requirement. I disagree. Option 4 does not satisfy this requirement, because you can copy it. Option 4 would require that asset manager get panics if the client calls manager.get with a handle after its asset has been deallocated. That is incredibly stupid. No, I don't think that 4 does in fact satisfy this requirement, because you'd have to check it and panic. That would be a runtime check. No, it does not satisfy that requirement. If there is a real chance a client may do this, another alternative would be for get to return an option with a reference to the asset. Fine, okay. Option 3 doesn't because it's an RC, it's reference counted, are jointly owned by every owner of the RC asset. The asset manager has no good way to ensure that all assets have no other owners and deallocate when it wants to. Okay, 2 I understand. I messed up. 2 is correct, because you can just put it into the asset manager struct. 3, however... 4, however, I don't agree that that is properly... I mean, sure, you could do it as long as you just panic randomly, but no. No, that does not, in fact, satisfy the requirement reasonably so. I still failed. Alright, let's continue onward. The box below contains the share context for each part. You are designing a simple user interface framework that consists of a tree widget, such as text and buttons. The API provides a widget trait that defines how a widget works. The API client implements the widget trait and calls it to render UI. Below are several proposed designs to implement the functionality. We have option 1, children must be self. We have a widget of type sized. We have a function, render. Right. God, I cannot think right now. Just a moment. Alright, are we chill? I am now low. Right, so we have below are several design to implement functionality. Yep, we have widget, function, render, self, returns a vector of holding in self. Alright. What? Right, what are we trying to do? The API is expected to provide a single widget implementable enum representing all possible widgets and implements the widget trait for it. Okay, sure. Let's repeat this. You are designing a simple user interface that consists of tree widgets such as text and buttons. The API provides a widget trait that defines how a widget works. The API client implements the widget trait and calls it to render a UI. Alright, so we got a public trait widget, which is a type sized. We have a function render on widget with a reference to self, returning a vector self that must be implemented. Okay. Alright, children are trait parameters. Right, option 1. This option 1. Children must be self. Right, so when you render, it takes in a reference to self and returns a vector holding self items. What the fuck does that mean? It returns a vector holding in. I guess somewhere there'd be a struct called widget or some vector holding in structs called widget or something like that. Which I don't understand. I'm sorry, I just don't understand. Perhaps widget finds how a widget works. The API implements a widget trait and calls it to render a UI. Right, so the what? I'm sorry, am I just an idiot or is I don't understand what's being asked here. I'm sorry, I just don't. Alright, so we got text and buttons, which are each a widget. Then you have public trait on widget, which when you render itself, it returns a vector holding self objects on the singular widget struct. What? Children must be self. So there are children of the widget, which are widget. What? Let's move on. I'm gonna get full wrong on this because I don't understand what the fuck, how that's implemented. I really just don't. Whatever. Option 2. Children are a trait parameter. We have a public trait widget of type children. Then we render it, taking in a reference to self, and we have a vector of all of the children. Right, children are an associated type. Right, so public trait widget, type children widget, meaning that there's an associated type of children, which is of type widget. And function render a reference to self, outputting a vector with self children. Sure. Children are a reference trait object. Right, so we're outputting a vector taking in a reference to dynamic widget objects. That's fine. That's fine. The children of widget can be widgets. That's fine. Children are a box trait object. Right, so we have a box, which is a dynamic widget, which holds a dynamic widget being held in a vector. All right. The API is expected to provide a single widget impl enum representing all possible widgets, and implement the widget trait for widget impl. What? Okay, I think I understand now. I think I do. Right, so this is an enum, which implements the trait widget, which has the function render, and the enum can hold all widgets at the same time in this, so one is fine. Single widget impl enum representing all possible widgets and implementing the widget trait for widget impl. Right, that's fine. Sure. Right, what's this? Children are a trait parameter. Children are associated type. There's a dynamic widget. We don't know. I don't think that works there. Box with a dynamic widget, which can't be part of that. I don't think I'm gonna get this right. I'm just gonna fly through this one because I obviously don't understand, which is fine. I'm just a bit annoyed at myself for that. Okay. I'm gonna calm down on this. Wait, we got 5 different options. Option 2, I think will work, sure. We have self children, which as long as it's an enum, I think will work, sure. Alright, we got a box, which is a... You know what? I'm just gonna say it's not gonna work. Because that's a trade object. And, I don't understand trade objects, I guess. Here's a box holding a dynamic widget. Representing all possible widgets and implement the widget trait for widget impl. Sure, I don't think that'll work there, whatever. How many of these? There are 3. Books, yep, okay, sure. Alright, the API client is expected to provide a unique struct for each possible widget and implement the widget trait for each struct. Each widget can return a vector containing widgets of any possible type. I think that the last one will work because it's a box dynamic widget object. That's fine. Returning a vector with a box dynamic widget. A reference to a dynamic widget, I don't think that'll work because the vector is holding dynamic widgets. That needs to be the same thing. An associated type. Everything must be of type widget. The type is children, which must be of type widget. Return a vector containing widgets of any possible type. I don't think that'll work either. I guess I'm not really familiar with this context. The syntax. Here we have a vector selfs of any type. Perhaps 2 will work. I'm going to say 2 and 5. Sure. Alright, what are we doing? Only types that implement the widget trait should be returned from widget. Right. So we have 5 and 4. That's fine because these are trait objects. That's fine. Implement the widget trait should be returned from render. Only types that implement the widget trait should be returned from render. Self children of type widget has to return that. I'm going to be wrong on this. That obviously could return anything that's a quote children. Children must be self. Yeah, it has to. If it is self, it must implement the thing that it called. You know what? Fine. Got one of them right. It was the last one. Okay. Right, what did I do wrong for everything else? I don't think I'm going to understand, to be honest. The API is expected to provide a single widget impl enum representing all possible widgets. Yep. The only one is 1. The only one is 1. 2 and 3 won't work? Fine. Oh, well, yeah, they won't work because it's returning a vector, you fool! You fool! No, I'm wrong. No, I'm wrong. I'm not a fool. I'm just an idiot. Right. If we represent all possible widgets as a single enum like this. Right, chill. Then we have a closed world system where there is a non-extensible set of possible widgets. There is only one implementation of widget and no need for dynamic dispatch. Therefore, only option 1 makes sense because render would only ever return other widget impl types. All other designs contain unnecessary complexity under the requirements. Alright, so 2 and 3 would technically work. However, they are utilizing things that don't need to be used. They're trait parameters. Yep, because we have a type children and the trait parameter here. It's unnecessary complexity. So both can be stored as a vector, that's fine. Sorry, as an enum, that's fine. I'm assuming this can too, but it doesn't need to be a trait object. By my understanding of how it works, I should have just said everything, but I didn't. I also misunderstood and didn't really know what this was doing, to be clear, or any of it was doing, to be clear. So that's a failure on my part. 1 is the only answer, and we got this one incorrect too. Right, unlike the previous question, now we expect to have a distinct type for each widget. I didn't get one of them right. Well, I got that one right. Alright. Therefore, a vector of widgets needs to be heterogeneous. It could contain widgets of distinct types. Options 1, 2, and 3 I'll constrain each widget render implementation to return a vector of a single widget type. Option 4 and 5 use dynamic dispatch via trait objects to permit heterogeneous widget vectors. To confirm, this is the one saying that a unique struct for each possible widget and implement the widget trait for each struct. Each widget can... I didn't read that. I don't remember reading that. Honestly, I don't think I really read that. Who cares, honestly? I don't understand this. I need to learn trait objects again. Adding to the list of things that I don't know and have not learned yet. The widget trait in option 2 does not constrain the children widget. It does not constrain that children widget. What the fuck are you saying? The widget trait in option 2 does not constrain that children widget. Sure. All their options do ensure return a vec for some w. All other options do ensure return a vec for some w or w widget. Fuck you. What? Alright, I'm angry and tired. Honestly, this is not helpful. I think I might just end it here and continue later. Honestly, this is just making me angry. I don't understand it. I need to learn a bit on my own. Dispatch inspiration is from here. I think I'm just going to continue tomorrow, or in a week. Yeah, this is it for tonight. I'm sorry for the weird, honestly quite terrible session. This is mostly my fault. I'm tired, I'm a bit upset. That's about it. Thank you for watching if you have watched. If you haven't watched, well, thank you, Steve.